It is only in large cities that cervical cancer screening and cancer treatment expertise is available. This means that the rest of the country has to travel great distances even to just get their screening done. Also, the low ratio of pathologists to cervical cancer patients seriously hampers early diagnosis. And as a result, by the time women reach a good pathologist, it may already be too late. But with grant support from the US India Science and Technology Endowment Fund, help is just around the corner. Adarsh Natarajan, founder of Aindra Systems Private Limited from Bengaluru, has joined hands with Louis August, CEO of Alexa Path Limited Liability Company from Brooklyn, New York, to develop a thoroughly unique system that aims to diagnose cervical cancer at the point of care, that is, at a primary healthcare center in a remote setting, and that too within 2 hours instead of 2 weeks. At IKP Eden in Bengaluru, Aindra Systems is attempting to automate a process which is currently manual in most parts of the world and which often leads to wrong diagnosis of cervical cancer. This portable automatic device being tested here will eliminate a common human error of keeping the biological samples and different chemicals for too long or for too short a period of time. This process of staining makes the cells clearly visible and helps pathologists by giving them a perfectly pre-processed slide that can then be interpreted easily and appropriately.
So a lady gives a sample, and in the next 2 hours she should know whether she is normal or she needs to have a follow-on treatment undertaken. That is our target.
And here's the second part of this innovation, which is changing the rules of the game. The smart microscope, which is the forte of the US partner Louis August and his team at this lab in Brooklyn, New York. Dhaval Palsana, the co-founder of Alexa Path New York, demonstrates how this image acquisition device works.
This right here is a universal smartphone adapter, so it can accommodate any size of smartphone in it. You can connect it to any kind of a microscope.
After loading the glass slide on the stage, a go-ahead is given from the control box, which allows automatic acquisition of all the images that are there on the glass slide. Then the data is transferred to a computer and stitched there.
Once the image is stitched, it's equivalent of having a glass slide on internet. You can actually Skype into the microscopes.
So let's say if there's a doctor in the United States who wants to access an operation theatre in India, he can Skype into microscope and control it from US and provide feedback live.
Without any of our devices, it's a simple microscope.
But what cannot be done with a normal microscope is converting a glass slide into its digital format. The image data acquired in this manner finally culminate in the computing unit of Aindra, which has all the intelligence to deal with visual computing using deep neural networks.
The deep neural networks are built in such a way that they enable this parallel computing to happen, which enables it to understand and differentiate between, let's say, a normal cell versus a precancerous cell versus a cancerous cell. Now, we've also tied in a bit of what we call as reinforced learning, where the algorithms are getting more and more intelligent every day as more data comes by.
And as more feedback flows into the models, some part of screening is done by the system itself, thus saving the time of cervical oncologists. Experts estimate that this innovation would slash the price of automated whole slide scanners from upwards of $100,000 to a fraction of it when it hits the market. And all of this is made possible with the US India Science and Technology Endowment Fund.